just let me know and I can sort that out with you. We are now recording. The way this is going to work is we're going to have teams one at a time present their presentations. The students, you should know what your schedule is. Obviously, the time has been a little bit pushed back a little bit, but the order is still the same. Judges and clients, starting with our judges, I do wish you guys, or ask you guys to maybe give a short, brief introduction of yourselves. Starting with Marianne, perhaps.
Hello, everybody. It's a real pleasure to be here. My name is Marianne Moffat. I'm a registered dietitian. I work with food services here at the University of Ottawa, and I've done this judging a few times. But it's really exciting to be with you again.
Awesome. Thank you very much. Will, would you like to go next?
Hi, everyone. Pleasure to be here. My name is Will Anderson. I'm presently the director of IT operations for Queen's University, but I'm undertaking my MBA through Telfer. Computer engineer background, master's in cybersecurity. Very excited to hear what you guys have to present today. Thanks for having me.
Awesome, thank you, Will. And our final judge.
Hello, my name is Carlos Valenzuela. I am the Quality Assurance Director for Talisman Wireless. We make antennas for GPS and GLONASS and all other constellations. It's my third time being a judge, so I'm excited to see what you guys are developing, and thank you very much for having me.
Awesome, thank you very much, Carlos. So like I mentioned, our presentations are going to be 3 minutes of presentations from each group, and then there's going to be a 5-minute question period. I have been told to be very strict with those times, so if you guys go over those times, I will have to be a little ruthless and cut you off. So make sure you stay within those boundaries. If you have any questions, obviously you can ask me in private chat, general chat, or just use a microphone. And yeah, so I'm going to stop sharing my screen and we can get started. So first up today is going to be group D3, if I'm not mistaken, design algorithm. Awesome. If anyone cannot see their screen, let me know, but I think you should be able to now. I'm going to put a timer on for you guys and let you know when you can start. All right, whenever you're ready, guys, go ahead.
Good morning. We are Design Algorithm. I'm going to be talking about the work we've done over these past few months with JAMS. JAMS needs a climate sensor add-on system for a food delivery drone that provides accurate and reliable data for temperature and humidity values. Constant communication to the flight operator is also necessary, so JAMS is able to tell when a value is out of the desired range. Our design follows a quick and easy 3-step process. First comes the attachment. The sensor is within a casing to protect it from any damage that may occur. That casing is then mounted in the inner top portion of the food delivery box. The sensor is then connected to the Arduino, which is responsible for the code and any data that is being outputted. The data is then sent to JAMS using serial communication. As you can see on the left-hand side, this is how the data will be received on JAMS's end. And on the right-hand side, you can see how our ARM module will be implemented to the food delivery box. Our team decided to tackle on these big concepts. The first and most important one being the response time and reliability. We found a sensor that is able to meet all of JAMS's requirements, starting with the response time. A response time of 2 Hertz can easily be obtained, and it is very reliable because it has a temperature reading of plus or minus 0.3 degrees Celsius. I'll be now passing on to Zach, so please make sure to pin his video so he can show a quick demonstration of our design.
Okay, so as you can see here, this is our food box that mimics the JAMS food box. It's made out of the same material, which is styrofoam, and this is to improve the fidelity of our product. Here's our Arduino board connected to the sensor casing and sensor that is underneath the lid, and it's protected by a waterproof mesh that is attached with Velcro pads. So now I will be doing the demonstration. I will take a thermos of really hot water to simulate a very hot and humid environment. I will put this inside the box like so. Close it. And now, if I flip my screen, Right now, none of the values are out of range, so there's no warnings posted. And now you can see that some of the values are out of range. So it's saying that the humidity is too high, and now it's saying that the temperature is too high. So there's a warning that will be sent to JAMS through serial communication. Now, as you can see through our demonstration, our prototype is able to alert our client if there are any sudden changes in temperature and or humidity that's outside of a desired range with complete reliability and consistency. Thank you for listening. Now, if there are any questions, we'd be happy to answer them.
Awesome. Thank you very much, D3. Now we'll move on to a 5-minute period for any questions from our judges or clients.
So the idea, the application would be basically for, let's say, food delivery or medicine delivery. What's the application that you envision this sensor on?
Yeah, I can answer that. So pretty much JAMS asked us, because this delivery drone is delivering food to rural areas. So pretty much they want to know the environment inside the box. So yeah, we have a climate sensor and it'll let us know what the temperature and humidity is inside of the box so that they know if the food is under like an ideal environment. So it's mostly for food.
On one of your slides, you presented a few different factors that kind of drove your planning. Were those requirements provided to you, or how did you come to focus on those? I don't know if you can pull the slide
here. I'll present my screen again. Tell me if you can see it.
Yep.
This one, you mean?
Yeah. How did you come to prioritize those?
Perfect. Well, JAMS was the one that told us some of them. For example, the response time. During our early on meetings with them, they told us that they wanted a sensor which is able to match the response time of the microcontroller they have on board. They have a Raspberry Pi and they're using 2 Hertz. So they want a sensor that is able to give them data at a frequency of 2 Hertz. And then lightweight, they had a weight limit on the entire module that it could be. They didn't want it to take up too much space on the drone because they still have to deliver the food. And they just want constant communication between the flight operator and our module. Does that answer your question, or should I clarify any other points?
So is it fair to say that, you know, they're prioritized based on the size of these bubbles? Lightweight was the least important factor for you in coming up with your design?
Yes, because especially for us, since it's just a sensor module, the actual sensor itself weighs ounces, grams. It doesn't make much of a difference. So yes, the size of these bubbles would represent the importance.
And tell me, what did you do to address the idea of the data readability? What actions did you take to meet that objective?
Well, as you could see from the demonstration, here I'll share my screen again. Maybe I should just keep sharing it. As you can see from the demonstration and the picture we have up here, for the data readability, we decided to include a timestamp, which ranges from seconds all the way to hours. It is in a table format, which is easier to read. So you have the timestamp on one end, then you have the temperature values and the humidity values, and then you have a warning statement telling you exactly what is out of range.
And now I have kind of a dumb question. Sorry, bear with me.
It's all good.
You have a waterproof cover that's covering a humidity sensor. How does the humidity sensor know if it's waterproof? You know what I mean? I feel like if it's waterproof, is it not being separated from the, protected from the humidity?
Yeah, I can answer that. We thought about that, but through tests, we tried it without the cover and with the cover, and there wasn't really any difference. So the fabric isn't very thick, it's very thin. And the only reason why it's waterproof is because there's a layer of polyethylene, I think. Yeah, polyethylene. So it kind of like shoots off the water. Like if you pour water on it, it just like rolls right off. It doesn't seep in or anything. But yeah, like we thought the same thing, but with tests, we saw that it really did make a difference with or without it.
All right, thank you.
And just maybe to at least to finalize on my end, just a recommendation. There's a membrane that is called Gore-Tex. You might Google it. It might help with that issue. Like it protects the sensor and also provides it lets the sensor detect humidity in the environment. So that's maybe something you can look at.
Okay,
Gore-Tex is the brand.
Gore-Tex?
Oh,
Yeah.
okay, yeah. Okay.
Oh yeah, I know Gore-Tex. Oh, the brand. I thought it was like, got it. Perfect. Thank you very much.
It's a brand, and inside it has like lots of options.
Okay.
Thank you very much.
Yeah, thank you for the suggestion.
We got time for one more question if anyone has anything.
How flexible are the thresholds on your sensor? You know, you've
like the range.
You've defined some bands there that work for your hot beverage, but what about other types of things that may need to be transported in this box?
Excellent question. I can answer that. So the temperature range can range from -40 degrees Celsius all the way to 80 degrees Celsius. There's no food that will ever reach those temperatures. And then the humidity can go from 0% to 100% relative humidity.
And the flexibility of establishing those thresholds, you know, as part of the broader system. So like you set warning for certain limits.
Yeah, so Jams gave us Jams kind of gave us a range to work with. And in like their very first presentation, they said like the range should be like about room temperature, and it should have like a range of like plus or minus 10%. So that would be like the range it would fall under.
And these are all things that are readily changeable, I guess?
Yes, it's very easy to change. Like if you look at the code, there's just like an if statement, and it's like if it's over this, you can just change it. Really.
we made the code very easy to change. So if anything had to be changed because the condition of the box were going to be different, Jams would be able to change it very easily.
Great, thanks.
Awesome. Thank you very much, D3.
Yep, thank you for your time.
In the meantime, it looks like D6 can get ready. Oh, looks like they're already ready. Judges, I'll give you guys maybe about a minute. You don't have to submit your judges forms yet. You're able to just fill them out now and submit that at the very end. Or if you'd like, you can submit them now, whichever suits you at best. So D6, I'll let you know in just about less than a minute when you guys can get started.
Sounds good.
Okay, D6, whenever you're ready, you can go ahead.
All right, so welcome everyone. We are Group 6, Team Diamond Hands, and we're here to present our violent shake alarm. So the first, to begin, there are a few questions we want to cover. The first being, what problem did we solve? So Jams Drone Delivery Service requested an add-on module capable of detecting violent shaking. We created a system that detects shaking and relays the severity of that shaking back to the operator. A second very important question to consider is who would even care about our system? Our system benefits the entire delivery chain, from operators to intermediaries such as storefronts to the consumer. Our system traces back disturbances, which minimizes fraudulent claims and acts as a form of quality assurance for the package.
So essentially, why are we the best choice? Our client Jams will only have to spend a little over $4 to buy the MPU6050 sensor and probably some little bit more wires because they already have an Arduino, Raspberry Pi, and a logic converter. And after we considered our client feedback, we implemented a real-time graph and a real-time status update of any shaking while logging the positional data onto a CSV file that can later be used in Excel after when the flight's done. And then lastly, JAMS can just easily readjust a threshold value from one line of code to just determine what their definition of violent shaking is.
So one of the most important questions is, why is this important now? And during the COVID-19 pandemic, delivery services have seen a large uptake, and the awareness of one's potential exposure of their food to a potentially deadly virus is ever apparent. But drone technology is a new emerging technology and hasn't been proven in the eyes of the public. Our product levels offers a level of quality assurance to the consumer that if something does happen to their food, the rectification process can begin as quickly as possible. To summarize our points, we developed a simple, reliable, cost-effective, standalone system as to compare to other integrated systems on the market currently that provides a good experience to the operator, is easy to adapt and modify the code as needed, and offers quality assurance to consumers of this new emerging technology. I'd like to pass this opportunity off to Jason, who will be demonstrating our prototype.
If everyone would like to please pin my screen, I'll now be going over our prototype and demonstration. It's just the 3 little dots by my name, and you should see pin my screen. So moving on, this is our current working prototype. We have an Arduino, which is hooked up to a logic converter, hooked up to a Raspberry Pi, all powered by a 9-volt power supply. Moving on to our demonstration, we have an MPU 6050 housed and attached to a clear box for demonstration purposes. On the screen currently is a live feed from the Raspberry Pi, which on the left-hand side is our data being outputted onto the Pi. From left to right, we have our interpreted status, pitch, and roll values, which constantly change based on the movements of the package. At the bottom is just a graph for a good live visualization to show you what is going on. Currently, our status is stable, but as the package is shaken, it changes to moderately shaking and then eventually violently shaking based on the conditions, as I'll now be demonstrating. Another big feature of our prototype is the ability to record multiple...
So that is final time for your group. Sorry to cut you off. But we will be moving into our 5-minute question period now for all judges.
Okay. I just, this was very, very good. The information, the CSV file, will it be transmitted to the source, or will it have like an SD card? What's your method of like archiving the information?
So the Raspberry Pi on board has an SD card as it is for storage, and all this data that's being transmitted to the Raspberry Pi is being created in a CSV file with the name of a date and timestamp. So once the log is over and the program is finished, then the file saves all the values into the CSV file. It's all on board the Raspberry Pi.
Thanks.
And what were we seeing in the graph again? There was a red line and a gray line.
Those are the pitch and roll values as they're being moved up and down. Those was the just the graphical representation of the numerical values.
And here again, I'm assuming the idea here is where we don't want the food to be abused, right? We want people to get it out and it looks good. So did you experiment with some of these things, like with these thresholds, or were they given to you?
No, we actually did the determination based upon, similarly to how Jason demonstrated. We attached it to a box that held either a drink or a sandwich or something, and we moved it around and we recorded the values we saw when the food ended up being disturbed, shaken apart, or fallen over. And we then determined the numerical values that are equivalent to those as our threshold values.
I'm thinking about that drink. Now that would fall over pretty easy though. Like how much damage had to happen to this food before you said this is severe, for example?
Well, that's the thing. That was the most difficult part of our development, was determining what constitutes moderate or violent shaking, which is why we ensured that in our code, it's one line with just changing the values of moderate or violent shaking, so that when our client does receive it, if they find that their values are too high or too low, they can easily adjust them to what their own needs are.
Great, thank you.
Yeah, it's interesting. I try to think about another application for this outside of food delivery. You know, those thresholds would definitely change if you were talking about a different type of package. But I can't help but wonder, you know, outside of the drone as well, have you guys considered other applications for this? I mean, you're using an off-the-shelf chip, right? And what you've done is taken the data off the chip and put it into a CSV file. Is there any ability to transmit that data off so that it could be used to maybe assist the drone operator or to do more than just sense that something has happened?
Yeah, so the idea behind this is that this data would be sent to whoever's operating the drone at the time, and they would be able to see from status updates that it would be either moderate or violent shaking. And from there, they would be able to do whatever JAMS has as their process to sort of take care of any potential liability when it comes to their food being damaged or disturbed. But as terms of other applications besides drone food delivery, it's not something that we've considered in depth.
Are there any more questions for D6?
Just
Oh,
in the image that you showed that you had a battery, like a big battery. So what charges it in the, like, what's the power source when it's in flight?
So the power source when it's in flight would be off of the drone's onboard battery.
Okay.
We would use an XT60 power connector, which is what JAMS uses as their standard, compared to a buck converter, which would downsize the voltage from 44.4 volts to the Arduino's usable 9-volt reading. And from there, the power is transmitted outside from the Arduino.
And that won't have a significant effect on range for the drone?
No, it should have no significant impact onto the longevity that the drone's able to go into the air.
Cool, thank you.
Awesome. If we have no more questions, thank you very much, D6. Judges, like last time, for our last group, we have about a minute or so to fill out those judging forms. And we'll move on to our next group, I believe is D7, PNP sensor. You guys can get set up. Awesome, looks like you're set up. I'll let you guys know when you can begin.
All right.
Yep.
Okay, you guys will have 3 minutes on the clock. You may begin right away.
Hello, judges. My name is Benjamin, and I'm here as part of PNP Sensor, along with Sammy and Will, to present our design. Perhaps the most fundamental and critical aspect of drone food delivery, our client's business, is to ensure the quality of the food. As such, we sought to design a temperature sensor module that fulfilled the needs and exceeded the expectations of our client, JAMS.
We opted for 2 DH22 sensors, image 4, to collect our climate data. The main parts of our design can be seen in the SOLIDWORKS images on your screen. The GIF number 3 is of this underside of the drone with our system attached underneath. The sensor guards, image 2, are equipped with ventilation slots and are elevated above the face of the lid to permit sufficient airflow. They are also crafted with a snag-proof design to minimize any potential damage. The Arduino case is designed with a snap-on lid and it's slotted to accommodate for overheating of the microcontroller. As the parts are located within the box, any damaging effects due to water or weather conditions are not being considered. Unfortunately, due to the COVID-19 lockdown, we were unable to print all of our parts.
Our client mandated that the design must be accurate. We met these needs while faithfully adhering to the project budget of $50, as well as expanding the user options. Thankfully, the majority of sensors on the market already satisfy our needs. While completing the prototypes, however, we achieved breakthrough results with our casing design, which is arguably the most unique and innovative component of our pitch. I'll now ask everyone to please pin Shayu's screen for the demonstration.
The current name is currently William. And yeah, so for the demonstration, oops. So for the setup, we have an Arduino that is connected to the computer via a USB cable, and also there's a breadboard in between the sensors that is inside the box and the Arduino. So for the software side, we have also implemented some cool features. Our device will have configurable setting that can be changed via serial message. For example, currently we have the data on request mode, which it can request the data for each time and our character R is sent. It also have a continuous data mode, which it will print the data as soon as it becomes available to the Arduino from the sensor. We also have an alert function, which can be turned separately on and off via alert 0 and alert 1. And as you can see, currently the alert is on. And as a demonstration, I will set the lower bound of the alert to 40 degrees Celsius. And as you can see, it is popping right now. And in order to turn it off, just via alert 0. And also, finally, we have an, if the command is not recognized by Arduino, it's simply going to return an invalid input. And that concludes my demonstration and our presentation so far. Do you have any questions? Oops.
Awesome. Thank you very much, G7. Well, 5 minutes for questions as usual.
Okay, you said that the casing design was the most innovative part of your project. Sell that to me.
All right, so when we were making it, we had taken into account a lot of different problems that could occur. So first off, the rounded filleted corners and the smooth design of both the sensor case and the sensor guard and the Arduino case. Those are to prevent, like, if anything's coming across and touching the module above the lid, it won't get caught, it won't get damaged in that way. It's also attached via M3 screws or any other type of fastener that the client would want to use. Also, as I mentioned, the slots, we didn't want to have any inconsistent data. Like if we have a guard that's closed off or it doesn't permit the air to flow through, it'll calculate for the sensors or the temperature and climate data inside the guard and not inside the actual box. So we did take into account everything possible to make sure that our need of precise data is being met.
So how does that align with the request of your client? You just tie that back for me, like what you were asked to do versus what, where you've spent your effort.
Benjamin,
right.
Yeah.
I'll take this one. All right, so the client requested that we be able to measure the temperature of the food and then relay that to the operator. Currently on the market, all sensors are pretty much the same with slight variations in their specifications. So whichever sensor that we use in the combination that we use, we would still most likely be able to receive consistent and accurate data, which are the needs of the client. However, by changing how we are protecting the design and how we are housing it, we can make our design more efficient and change it and raise it above the current benchmark in the market.
Great, thanks.
Right, now I'm going to ask another question. If the objective here is maintaining food temperature, but what you're measuring is really the space around the food, how do you know that space around the food is a good measure of food temperature?
Will, do you want to talk about the test that we did?
Yes, I'll take this over. So as of due to the way food are packaged, we don't just place the food directly into the box. We will always package them in some sort of container, and usually it will be bagged with either a paper bag or a plastic bag. I did a test with with a simple takeout styrofoam box that's filled with rice and plastic bag. And it turns out the sensor can actually pick up the changing temperature, and the change is although the change is not very big, it still can be detected. It is greater than 3 degrees Celsius over a span of 2 minutes.
Say that again. That's really interesting. So if there's a 3-degree drop in the food in two minutes, it gets picked up in the space temperature.
Yeah, it gets picked up. Yeah.
Well done.
Mm-hmm.
I think we have time for one more question if anyone wants. Not perfect. Thank you very much, D9. Oh, sorry.
Very much,
D7.
judges.
Thank you very much.
Thank you very much.
Thank you very much.
D9, you guys can go ahead and get ready.
Okay, let me know when I can go.
Will do.
Hello, my name is Elsa, and along with my teammates, we formed the Niners, and we decided to do the emergency beacon. Problem statement. Our clients needed an emergency beacon that relayed location and altitude data of the downed drone to the remote operator, as well as flashing lights and an automated message to alert nearby pedestrians. As you can see in this diagram, we have our input subsystems of the altitude and location, as well as our output subsystems of the voice and light, which are reliant on the altitude subsystem. For every subsystem, we tested first using Tinkercad and then did isolated and both integrated testing, which is exactly what you can see here for the altitude subsystem. For the location subsystem, unfortunately, as it was very hard to get it to function, we had to do a lot more isolated testing. And here are some code results. For the voice subsystem, we use an automated message using the Talkie library. And unfortunately, as our speakers are not loud enough, we could not hear it from a certain distance, but I can show you in the video the sound. So if you did not hear, the words were danger, danger, operator is on alert. And for the light subsystem, we used 8 lights, but unfortunately, as we started soldering, we could only use 1 light in the actual demo, and I'll show you in the picture video. So the lights will turn on one after another. And I'll pass it off to Karen to do the integrated subsystems.
For the integrated system, we connected the 4 subsystems to one Arduino using our final code. We had a fully functional prototype with the voice and light subsystems, dependent on the altitude subsystem. To reach our goal of a functional system, we performed many tests to verify both the wiring and the code. Some were successful and some failed, but that did not stop us from pushing through the challenges to reach our goal. Unfortunately, we were not able to solder because of COVID restrictions, but we had already started, as Elsa mentioned, and in the picture at the bottom right side, you can see our lights being soldered to the proto board. Now, you might be wondering why us? Well, given the large number of tests performed and the high level of organization our team had, we built a fully functional emergency beacon that transmits live and accurate data to the drone operator, as well as notify bystanders of a downed drone in case of an emergency. Not only does our system work, but thanks to our water-resistant laser cut case, it also looks aesthetically pleasing. If we have time, we will move on to our demonstration, and Elsa, you can take it from there. You're muted.
So we have our emergency beacon here, and what I'm just going to do is lower it. I'm going to lower it, and then I'll show the code results. And
we will be moving on to the question period. Feel free to take some of this time for your presentation if the judges would like to see it. But yeah, we will move on to our 5-minute question period.
Okay. Yes, so if you have any questions, please let us know.
Did you have like the specification, the threshold about when the alert triggers?
Yeah, so you're asking what our altitude reading would be to signify down drone? Okay, so according to Transport Canada, they would say 30 meters would be the absolute minimum for the threshold value. And our sensor has an uncertainty of plus or minus 1 meter. And if you also take into account that it's using barometric pressure and temperature, we would give a little bit more breathing room with, say, 10 meters, because on different days it could read different readings. So for our purposes, we didn't use 40 meters because obviously we don't have a drone and I have to use my computer. So we just used, our threshold specific value was negative 0.6 meters, and it would lower to that distance, and then it would, everything would turn on.
Super, thank you.
And so the idea here is that it's a beacon for a fallen drone. Now that's a pretty large box right now. Is that,
Yes.
it's going to sit on top of it? Or do you think you would shrink it down if you?
So that's the plan for now. Based on the information we had originally, that's the box we were able to make. But we also have in mind, if we had more time, we would definitely think about making it more aerodynamic. So it can sit on top of the drone without it having any restrictions on how the drone is moving. We definitely had extra space because there was a lot of changes happened throughout the tests. And as we tested more, we found out more things. So originally we were going to use 2 Arduinos, and then we ended up using only 1. So that definitely affected the case size. But if we had more time, we would definitely have that we will like put it into consideration to have a more aerodynamic case.
And what was the weight? Did you weigh it?
Yes, we did. And it was about 200 grams, but I can verify that in 1 second. Okay, no, it was 492 grams as just the box.
Okay.
Yeah, and we didn't have a more sensitive way to measure it afterwards. We were only able to do it when we went to Makerspace, but then it closed down and we couldn't measure it with the components inside.
Okay, great, thank you.
No worries.
How loud is the audio alert there?
So right now, because we had very limited budget, we couldn't purchase a really good speaker. So you have to really go really close to the speaker to hear it right now. And I think one of the things is because we use the Talkie library, which is, it already had programmed words in it. It's easily changeable if you purchase a better speaker and you attach it. All the attachments are the same. The code would not change. Everything would be the same. It's just based on the limited budget, we couldn't purchase a better one. So it's very difficult to hear, to answer your question.
Yes, I definitely had to put the volume up when we were playing the video.
And I have one other question. You said you're also measuring the barometric pressure and the temperature, and all of that's going into this calculations. Can you explain that a little bit more to me?
So it uses both barometric pressure and temperature to read the actual pressure. So first it would go with pressure, and then it would use that barometric pressure, which is essentially the weight, the air density at a certain measurement, and then it would transfer that into an altitude reading using, you would use just, it's converting units. It's not a huge calculation. And then it keeps doing that at certain heights, and it would then output that to the serial monitor.
Okay, so that's the math that tells it how high it is in the end.
Yes.
Cool, thank you.
Awesome. Well, thank you very much, G9.
Thank you so much.
Judges will have about a minute to fill out those judging forms. And in the meantime, D10, Sensor Society, can get ready to present.
Am I good to start now?
Just a minute, I'll let you know.
Okay.
Okay, whenever you guys are ready.
Okay, good afternoon, fellow judges. Have you ever ordered food and been disappointed because it arrived to you too cold? Well, save your disappointment. Sensor Society's temperature and humidity system will be able to tell you in advance of your food arriving if it is at a desirable temperature for you to eat. Jumping into our design process of this idea, one of the first things we did to ensure we met the client's needs was develop a problem statement. We used this to enhance all of our ideas and make a better product overall. That statement was to have a continuous exchange of accurate data with the operator about the package's climate and ultimately determine the good standing of the buyer's package. On the next slide is a CAD model, and it shows where we plan on placing our module on JAMS's drone, and where the placement is the most optimal, where we can get the most optimal accuracy out of all the sensors.
Some of the unique features that really set our module apart from other competitors is that our module only requires 12 M3 screws, which is ideal for the client, as well as the entire system only weighs 0.113 kilograms. To put in perspective, almost as heavy as a deck of cards, hence putting little to no effect on the drone. This is thanks to our system, including really small components and simple wiring. Overall, this makes our module very easy to install for the clients, but still very accurate and effective for our clients' needs.
Ben, I think you're muted.
No. So looking at the code, initially JAMZ told us that they would want 2 sensors. So as you can see in the first snippet of the upper code, so we're using the average of both sensors for the temperature and the humidity. And on the bottom snippet, JAMZ told us that they would like us to output a flag code data. So that would be just a one-time data of if the food is no longer in good standing, instead of sending out constant data, which would take out a lot of JAMZ's memory on their Raspberry Pi. So now I'm going to run a simulation. So that's the code. And here's a simulation. So if you look closely, you can see that the humidity values that JAMZ wants is between 55 and 50. So here the humidity values that we're printing out is 31.59. So they would not be in the desired range, while the temperature values would be. So it does not print the error message.
Thank you. And does anybody have any questions?
When you guys started that presentation, I thought you were going to say something about talking to the client. Like, you know, I want to know if my food is hot. I want to know if my humidity is good. Did I just misinterpret that, or did you think about that as well? Like to send messages to the receiver of the food?
Yeah, we definitely thought of that. Like that's sort of if we were to continue working with JAMZ on this, that would be in like the future works, maybe developing an app that the customer would download, and the data that's being sent to the drone operator could just relay that to whoever's receiving the package.
Interesting. And now you just have to tell me, what was the significance of the 12 screws? You said
it's not really about the 12 screws, but it's more about the type of screws. So JAMZ had set a requirement of certain specific type of screws that they'd wanted, which makes it easier for them to install on their drone as well. So then when we were designing the CAD screw, we made sure that the thread was according to those screws, specific ones.
Can you go back to the picture of your sensor?
This one here?
Yeah, can you talk to me a little bit about, some of the environmental analysis you might have done here about using this to detect temperature and humidity?
So first of all, detecting humidity and temperature is really hard when you're in a box. So the first test we ran was, we ran a test we're comparing the temperature of a coffee to the temperature our sensor was relaying. But we were measuring the inside of the coffee temperature, which is what Jamsey would like us to relay, right? You want to know the temperature of the coffee, not the temperature of the box. But the thing is, the temperature of the coffee and temperature of the box are very different. So depending on each substance will have a different thermal capacity. So they'll exchange differently with with their environment. So like for a sandwich, they wouldn't really exchange a lot of temperature compared to a hot coffee that would. So here we kind of used a ratio. So we decided to plot a ratio. So we only did ours for coffee specifically, but the values could be easily changed. So we plot out graphs and made a ratio between the temperature of the box and the temperature of the coffee. So we arrived at about a ratio of 3.2, I believe. So if you take the temperature of the box and you multiply by 3.2 on each data points, it will give you the temperature of the coffee inside.
And so, operating this sensor in a humid environment is that going to be okay? Or
so what's special about the SI7021, they have inside each one of them, each sensor has a heater enable function. So once the heater becomes the humidity becomes too high, a heater function will activate, which will defog the heater, will defog the sensor.
Does this unit have capacity for more than one sensor? Because I'm thinking, imagine that you have a coffee and a sandwich in the same box kind of thing. How would you manage a situation like that? Or did the user, the customer was only seeking for each individual product? How would you handle that? Like if you have a mix of many products in one basket?
So our module actually contains a multiplexer. So this could also we'd have to cooperate with Jamsey, and we could have two sensors, but on different sides of the drone. And then we can have the multiplexer choose which sensor they'd want to extract the data from. And then based off of that data, we can put in specific range points. So for the left side of the drone sensor would extract data for the coffee, which would have a higher point for the temperature, whereas the right side of the sensor would extract data from the hamburger, which would have a lower temperature.
Maybe because this is not part of the scope of your project, but do you know if Jams or the end user, would they have like a section for cold food and another section in the drone for hot food, or do you know anything like that? And just as a curiosity.
I believe our client can answer, but I do believe that it's going to be in one whole package in the styrofoam box. But yeah, if Mohammed wants to take this, then okay, good answer then. Yeah.
I think he was satisfied with your answer. It's a good answer. Great job, guys.
Thank you.
Thank you very much, Sensor Society. Judges who have about a minute, like usual, fill out those forms. In the meantime, D12 Hot Solutions can get ready.
It says host disabled participant screen sharing.
Disabled?
Yeah.
That's weird because we just had other groups presenting.
I'm getting just a message saying host disabled participant screen sharing.
How about trying now since someone else was presenting? It might have been a little bug.
It's just saying host disabled participant screen sharing. I'm not sure why. Yeah.
Is everyone else in the group having this issue?
Ilda, can you try sharing? It's abled for you? Weird.
Yeah, very weird. One thing you could try is a good old turn off, turn on. Maybe exit the breakout room and try to come back.
Enter again? Sure. Leave the breakout room or leave the whole meeting?
Maybe breakout room. Try breakout room first.
Yeah, same message.
Okay. Everything is enabled on my side. Is anyone else in the group able to share your slides? Does it need to be you?
It doesn't have to be me, but June can if he wants. June, if you could.
Want to give that a shot, June?
Yeah.
Great. Does that work?
I am able to
yeah.
see it. Very weird. Sorry about that, guys.
That's fine.
Awesome. Well, on that note, you guys will have 3 minutes whenever you want to start.
All right. Well, hi, everyone. We are Hot Solutions. As a team, we've designed the climate sensor module for JAMSI. JAMSI required a lightweight system for accurately monitoring the humidity and temperature of their delivery box. The system relays information back to the drone operator of any significant changes to ensure the quality of food. We've managed to create that and more. The system features a lightweight design, about 60 grams total. Protective casings are water resistant and easy to assemble. Safety ranges are set at 20 to 80% relative humidity and 20 to 80 degrees Celsius, but depends on the type of food on board. Anything outside that range will send an error message.
So to build our solution, we made use of 2 sensors, each housed in their own protective casings. As mentioned, they are placed to sense both the temperature and the humidity of whatever inside. Our additional sensor increases the system's accuracy, reliability, and redundancy, since with the additional sensors, we can get more accurate readings and measure temperature across the box rather than in a small portion of it.
Within our program, the data collected from the sensors are averaged out and filtered through a filtering algorithm. This process data is then used to determine if the conditions within the box is unideal and sends a message accordingly. Our program is very flexible for the end user, allowing for dynamic changes in timing control of warning messages, control of ideal temperature and humidity ranges, and the stop function to prevent the code from running while it's not delivering any packages, which saves on power and bandwidth usage. So here's what our filtered data and selection features look like. And now I would like to ask everyone to pin Christina for the live demo.
Okay, so for our demo, what I'm going to do is I'm going to put this jar of hot water into our box, and then we're going to see how the temperature and humidity changes. So, okay, now if we come over to our code, should hopefully be able to see that our temperature and humidity are both increasing. And if you wait a minute, when our humidity goes above that 80%, we'll get an error message. There it is, the humidity not ideal. So everything does work. And I'm going to pass it off to Christian to finish us off.
Future steps for our climate system. So some ideas that we thought of are possibly coating our cases with a resin or a spray to aid with waterproofing. We'd also look for solutions to possibly reduce the size and cost of our system. And lastly, we would like to attach our system to JAMSI's drone to see how it operates while the drone's in service and how all our pieces fit together. Hot Solutions would like to thank you for listening, and please feel free to ask us any questions.
Awesome. Thank you very much, guys. About 5 minutes for questions.
Well, just you mentioned a very like a key element, how to reduce maybe the enclosure, and just as a comment to maybe some ideas. There's something that is called conformal coating that you can put on the sensors and all the boards. So you can eliminate the enclosure and you just stick with the minimal amount of weight. There's also something that's called techno melt, which is basically like dipping the sensor in some sort of like amber-ish kind of material, and it protects that, and that will relieve you from having an enclosure and just have the minimal space required and that kind of stuff. So that I was when you mentioned that idea popped in my mind. I just wanted to put it out there. Maybe that will help with your project and minimize costs as well.
Thank you very much for the recommendation for the coding.
I'm going to ask a similar question I asked another group. You've got your cases all tightly waterproofed. What about access, for airflow to access your sensors?
So, or our cases are a little bit different, is the actual sensing component of the sensor is open. The electrical components are hidden, and that's what we're waterproofing. But the actual sensing component, which is actually taking that steam from the humidity or the temperature itself, that's out in the open, and we want that to be out in the open so it can take in the data.
I'd like to ask you guys the question too. How are you reconciling box temperature to food temperature?
So the big thing is that first off, the box itself is insulated. So that means that we're assuming minimal temperature loss to the exterior. So really what we're trying to see is how much of a temperature difference we're getting to the sensor. And that's going to tell us if it's more than, let's say, 2 or 3 degrees, we made it so that it's saying, okay, there's a problem. We're venting out way too much temperature. It's getting way too cold. But really when inside the box, if it doesn't maintain a certain temperature, depending on what's inside, it will send a message saying, hey, the temperature is way too low, or it's losing heat.
Quickly pull up that slide that showed your code.
Great. This part or?
Right there.
This.
Yeah, can you just talk to me a little bit about spam prevention and what you're trying to do there, what you're trying to achieve?
All right, so Jamzy, they said that they don't want continuous information of or data. They just want to know if there is something wrong with the conditions within the box. So it's kind of pointless to update them about like, the temperature isn't ideal. It's not gonna change from second to second that significantly. So it only sends a message every, let's say in this case, it was given 20 seconds. So we'd just update the operator about, oh, there's an issue. And then just not, instead of spamming the operator with just like, it's not working, it's not ideal. Yeah, that's just what the spam prevention is for.
Thanks.
Well, awesome. If that is it, thank you very much, guys. Well done.
Thank you very much.
And well done to all the groups as well. That does conclude our presentation.